And to make it this, you needed one parameter here to make it this proportional to change to the equations. That's with R.
Doctor,
Yes.
are these all derived from the fact that the system is in equilibrium?
Yes, yes. Equilibrium conditions. Yes, it should be supposed always. Yes. Because when you take the derivative here, you know, you have a partial derivative of ln omega prime runde e prime r, no? So this is actually 1 over kbt prime, the energy to the rest of part of the in this diagram. So that's beta prime.
So everything is dependent on the rest of the...
Yes, for the rest. Yeah. We are looking to find the probability of the specific energy of the rest of the system. Yes. But the equilibrium condition existed there. You know, this is the R and T, and the rest of the system was R and T prime, for example. R prime and T prime. And when you want to find the probability of some specific value of the energy from the rest of the system, so you get this expression, partial derivative, and this is B prime. If you are not sure that the T prime is equal to T, so it remains here like beta prime. So, and it breaks the rules actually. It breaks the rule because it breaks also the conservation energy condition. These conditions. If beta prime is not equal to the beta, or if T prime is not equal to T, even the conservation of energy will break. So, you know, any probability, the sigma of the probability should be 1, so you should not have the probability greater than 1. So, with these conditions, you didn't get the E minus beta H. R will be 1 over sigma exponential minus beta. So, Pi ER will be exponential minus beta ER over sigma exponential minus beta. This probability is different from the other type of the probability which may you read it in the mathematics. For example, you have a coin and the coin has a 2 possibility only, yes? So this possibility I call it F and B. 2 possibility. So if you just for one time, if you drop down one time just the coin, so for one time, so the probability at the F and probability of the P is 1 over 2. Yes, for one time. And here you are sure that the sigma Pi F plus FB. But tell me that if you do this experiment more than 1 times, for example, if you do the experiment n times and n be bigger than 1, so you drop the coin more than 1 times, 2 times, 3 times, 500 times. What is the probability of the finding F, and what's the probability of finding the other face? So I want to tell you that this probability comes by probability of defining this will be, for example, if you do your experiment n times, and n is a big number or any other number bigger than 1, and if you are looking to see n times the F, for example, you expected that I want to know that what is the probability to see 20 times the F when I drop the coin 100 times. So this is the number of my desired number, what I want, and this is the total number of the. Oh, you know that this. You know this is a question actually, very well. All comes from the something which called a binomial theorem, huh? Binomial theorem say that the A plus B is the R from N binomial theorem. This is the probability actually. N factorial, R factorial, N R factorial. This is the probability. Actually, this is just the appearance. This is the appearance. Just to explain that, I don't know how to say that this is a. I want to mention here that this shows that this is, for example, F will appear n times, and the rest of the system appears n minus n times. So anyway, I think this is better than that explanations. So the probability comes as a coefficient of the some binomial things. And for example, if you have an n3, and if you wanted to know that what's the probability of observing just one time the A, so you can just calculate this probability, this factorial. I want to tell you that in the set theory, in the mathematics, the probability is normally factorial. No? You never see that the probability like exponential. And this is the first difference of the probability in the statistic and the probability. Second is that the probability here has dimension. They have a dimension. And here you don't have the dimension. How many coin will show you the F or B? It doesn't have any dimension. But here the quantity have the dimension. So the energy has dimension. And the dimension of the energy. So you have dimension. So the probability in statistical physics are a bit different. So they are not only just simply factorial. They also have the dimension of the energy, temperature, other parameters. So let's, starting part of this chapter was really hard because, but the rest of the chapter will go very smoothly, you will see that. Still we will use, this is all about the counting actually, so that will be always about the counting in case. So I want to, before to go to through the calculus, because you didn't see, so far you didn't see the Hamiltonian, so you see just the energy in the probability. So PR is exponential minus 1. I want first of all